Alright, in this last video for Unit 4, we're going to just take a brief little look at this concept of power. So, power is the measure of how quickly work is done. Another way to think about it is that it's the amount of work done in a given time. So it's the rate at which work is done. And so the symbol is P. The formula is just simply work over time. And I'll write it over here because there's different ways that we can look at this equation. So remember that work can also be changed in kinetic energy over time, but it can also be F delta X. We've been using delta X, not D. Again, that's going to be preference of the book and the teacher, which also leads to, because delta X over delta T is velocity or speed, so it's going to be FV. Okay, and again, you do have this attachment of that cosine of an angle running around there, especially if you have force. For us here in AP Physics 1, it's just simply just work over time. The unit is watts, which is abbreviated W, but I don't want you to get it confused with the variable for work. Now, 1 watt is such a small unit that oftentimes in problems they're going to give it to you the power in kilowatts, and so 1 kilowatt is 1,000 watts. In fact, if you look at your electricity bill, you would see something called kilowatt hours. Okay, so this is the unit for energy consumption, which is actually a unit for work. Okay, it's weird because the actual unit of watts is a joule per second. Okay, which may pop up sometimes in some multiple choice question because it's a unit of energy over a unit of time. Now, a more common power unit, especially for those who enjoy cars, is horsepower. So 1 HP is 746 watts. Okay, so when Watt was developing the steam engine, he had to kind of relate it to what farmers of the day had, and so what he would say is, this machine that I have, right, can replace that many horses. So horsepower literally means the power generated by 1 horse, and the conversion is 1 HP is 746 watts. And this has, again, to do with cars, right? Car engines are measured in horsepower. But that's the engine horsepower. That's not necessarily your output horsepower. Okay, so just think about that. So another way to think about power is that it's the rate at which energy is transferred. Again, so this just turns our equation right into P equals E over T, or delta K over T, or delta U over T, right? So any energy that can be transferred, right, the second you change it with respect to time, you're now generating power. And that's what this example problem looks at. So it says, to pass a slow moving truck, a driver has to accelerate their fancy 1,300 kilogram car from 13.4 meters per second to 17.9 meters per second in 3 seconds. What is the minimum power required to do this? Right? So if we start with our equation, power equals work over time. But remember, work is change in kinetic energy. And so we can just simply do 1/2 mass times v squared minus vo squared over t. And so that's just going to be 1/2 times 1,300 times 17.9 squared minus 13.4 squared over 3 seconds. Okay, and so we plug that into our calculator. So 0.5 times 1,300 times 17.9 squared minus 13.4 squared. Divide that by 3, and so we're going to get 3.1 times 10 to the 4 watts of power. But then if I convert that to horsepower, really to see how much did the engine really use, 1 HP is 746 watts. And so if I divide that by 746, you find that you get approximately 41 horsepower, right? And engines generally are like over 100 to 500 horsepower, depending on what kind of car you want. So this is a fancy car, so it probably has a horsepower in the 300 range, right? That's for the engine. So you can see that the engine doesn't transfer all the horsepower to the car. Okay, so you can have all these car guys spew out these numbers, and you can say, well, what are you actually outputting? Right? What are you actually getting out of your car? Because it's not going to be 300 to 400 HP. That's what your engine does. What do you actually get out? Right? And so they'd have to do this kind of test to it. So that's the end of Unit 4. We will move into Unit 5, and that's going to focus around momentum. And so, again, energy is a big portion of your test. It's, again, like 16 to 24%, or in that 14 to 20% range. Okay, so this is a big chunk of the multiple choice section. Probably have an energy question on the free response because, again, a big chunk of your test is centered around this. And so I look forward to seeing you guys when we talk about Unit 5.